Hello everyone. In this video, I'm going to introduce the basics of object-oriented programming, or OOP, in Swift. So I've got a brand new Xcode project open that is a macOS command line project. So far, I just have the main.swift file that is provided by default with this project template. We're going to take some notes in this file, and then we're going to create a few new files representing some object types. Now, this video is going to span over multiple topics, but those topics are also going to span over multiple videos. So there's a lot to cover related to object-oriented programming, and I'm not going to try and fit it all in one video. This will be an introduction to kind of an overview of the three types of objects in Swift, and then we're going to get started with the basics of implementing a class. So let's start by getting rid of this print statement. We don't need it. And let's review what is a class. Well, a class is a collection of state and behavior that completely describe something. So when I say state, what do I mean? Well, if we're talking about, say, a book, for example, which is a really commonly used example of an object to introduce OOP, then some state about a book might be its ISBN number, its title, its author, its price, etc. So when we talk about state in terms of Swift, we're talking about properties. These are properties of a class. For behavior, this would be, operations that act upon the state. So for a book, this might be something like discounting the price or maybe adding an additional edition, something like this. When we talk about behavior in Swift, we're talking about methods. And then just to recap, perhaps your intro to OOP class you might have already taken. What is the difference between a class and an object? Well, a class is like the blueprint for creating objects, and an object then is an instance of a class. All right, diving into OOP in Swift, one of the most important things to know is there are actually three types of objects in Swift. So the first one is the one we've been talking about and kind of reviewing our previous knowledge of, and that would be the class. The second one is a struct, which if you've worked with structs before, perhaps in C or C++, structs are actually really powerful in Swift. In fact, common types, like what we think of as primitive types, like ints and doubles and floats, those are actually structs in Swift. They're not class types. So that's kind of interesting. And then the third one is enum, which is an enumerated type. We're going to start with classes in this video and then carry on to some more advanced features of classes and then structs and enums in other videos. So the second most important thing to remember about OOP in Swift, this is the first one. The second one is that classes are passed by reference. All the other types, structs and enums, those are passed by value, or they're known as value types, okay? So for example, I just said that like int and float, array, dictionary, set, etc. These kind of basic types are structs, which means they are passed by value into a function or method. But if you have an object that is of type class, it's passed by reference. So important to know. All right, so we're going to code up an example book class, and then we'll make some book objects. So let's head over to our project navigator in the left sidebar or side panel here. And on our project folder, we're going to click New File. And here we're going to be prompted to choose a template for our new file. Let's choose Swift file and then say Next. We're going to name this file book because it's going to store our book class. All right, in this file, we're going to define a book class. It's going to be quite simple at first, but then we're going to come back and add more features of OOP in Swift to our book class. And we're also going to convert our book class into a book struct, and we're going to add a genre enum or enumerated type to our book. So we're going to get a taste of a lot of different facets of OOP just by working with a simple book idea. All right, so let's declare our book. We have class book. Nothing too crazy so far. We're going to specify our properties at the top of our book class. So let's just come up with a few just to get started. Let's do an ISBN, which is a string that is initially empty. Let's do a title that is a string that's also initially empty, and an author, an initially empty string. Just to mix things up, let's do a num pages, which will be of type int and initialized initially to 0. All right, so we've already got some properties here, so we should be able to start making some book objects, and in fact we can. Let's take some notes. So an initializer is like a constructor. It's used to initialize new objects. If when you create an object, like a book object, if you initialize all the values for your properties at declaration time, then Swift is actually going to give you a default constructor. And I should say initializer, not constructor. My Java and C++ ways sometimes kick in. So let's try this. So let's head over to main.swift and let's start making some book objects. So let's have a book class driver function. All right, so let's go ahead and make our first book object. I'll call it book1, and I'm going to assign to it a book object. Now, this is okay to do because, as I said in our notes in book.swift, that if you initialize all the values for properties at declaration time, as we've done here, empty string, empty string, empty string, 0, then we get a default initializer for free. So here's my default initializer that I get for free in action. I'm just getting a warning saying that I haven't used this variable before, or this variable yet, and that's okay. So now let's say we want to be able to parameterize our initialization of books, right? Like I want to be able to declare a book for Harry Potter and the Sorcerer's Stone, or a Game of Thrones, or something like this. So if that's the case, then I'm going to actually have to create my own initializer, which unfortunately means we're going to lose our default value initializer. But that's okay. So let's go ahead and do this. So the special name init is used to declare an initializer. So I'm going to have a parameter for the ISBN, which is a string, title, which is a string, author, which is also a string, and then num pages, which is an int. All right, so in here, I'm going to specify that the ISBN property should be assigned the value of the ISBN parameter. But what I have effectively set up here is shadowing, because I have the same name here as here. So to be explicit, say I want to use the property ISBN, not the parameter ISBN, I can qualify the ISBN name with the keyword self, which is referring to the current object being initialized, okay? This is like this if you are familiar with other programming languages like C++ or Java. If you're from a Python background, then you've seen self before. So I'm going to do self.isbn is assigned ISBN, and then repeat this for title, author, and num pages. All right, so now I have a parameterized initializer, which I'm going to head back over to main.swift. And if I try and run this now, I've actually broken my code because now I don't have that default initializer anymore. But I have this nice initializer for each of my properties that I've created. So let's do the ISBN for Harry Potter and the Sorcerer's Stone, 30495-3452, title, Harry Potter and the Sorcerer's Stone, This is by J.K. Rowling, and I'm just pressing tab to jump through these placeholders here, and 345 pages. All right, now my code compiles again, which is awesome. I have no output because I'm not doing anything so far, but now I have a parameterized way to initialize book objects. So let's head back to book.swift and just take some notes about what happened when we declared this initializer. All right, when we add an initializer, we lose the default value initializer. You might see some initializers that look like this. This is just kind of fun to be aware of. If you're in the documentation, you see something that looks like this, init question mark, open paren, close paren. Recall that I stated back in one of the videos about optionals, whenever you see a question mark, think optional. Well, this is called a failable initializer. And what it essentially means that if an initializer fails, meaning it cannot initialize an object, it will return nil. Okay, so it's going to return an optional. Nil if it fails, or an object successfully initialized if it's successful. So that's kind of another fun application of optionals. I won't do an example here, but you should be aware of it in case you see it. Now, we might have some methods that operate on the book class or a book object. We can put them here. They can be instance level, meaning they belong to an object, or they could be class level or static, meaning they operate at the type or the class level. All right, so what I want to do next is talk about how we can print out our book objects. So let's head back over to main.swift and let's print book 1 and see what happens. All right, so I see this oopfun.book output, okay? So oopfun is the name of my project, and then book is the name of my class. So I'm really just getting kind of a fully qualified or resolved type name when I'm printing out my book object, which is not very informative. This is kind of like what happens when, say you're in Java and you print out a, object of a custom class you've created, and you get some, information about the type and then some information about its like hash value. It's not very informative, right? So in Java, what you would do is you would override the inherited toString method in order to provide a string that represents the current book object. Well, we're going to do something very similar in Swift so that we can actually see some of our property values or whatever we want to print out when we print out a book object. So let's head back over to book.swift, and in here, let's take a little bit of notes. So let's start at the top with what is a protocol. So a protocol is a set of state or properties, okay? Recall we were talking about properties in our main.swift file, and behavior methods, okay? So state and behavior that a class or a struct can promise to implement. So if you implement the state behavior defined in a protocol, then this is called conforming to a protocol. And if you're coming from a Java background, then this is like an interface in Java where you would implement the interface. So we're going to learn our first protocol right now, and that is the CustomStringConvertible protocol. And it is kind of a long name, but it's a simple protocol that has only one property in it. And that one property is a string description, okay? This is kind of like toString, the method in Java, but this string is a description that is a property, okay? So it's associated with state, not with behavior. Okay, so there's a little distinction there This is a property we're going to do in Swift to describe the string, but toString in Java is a method, so it operates on the object. Okay, so let's take a stab at this. Up here with my properties, I'm going to add a new one here. Description is a computed property, which means it doesn't actually store any data, but when it is called upon, it is going to compute a value based on stored values. So let's try it. So we've got this variable called description, okay? Although it's looking like it's going to store a value, it doesn't actually store a value. Instead, it's going to compute a value by executing the code in this code block defined by curly braces that I'm going to put right after I declare this variable. And in here, I'm going to return a string that represents the current book object. I can really put here whatever I want. Let's just do a title by author using string interpolation. Okay, this is called a computed property, and they're really cool in Swift. Rather than maybe storing this string, which could become out of date if the title or author were to change, whenever I need the description property of a book, I'm just going to compute that property based on the value of other properties that store data. This is a really cool feature, and we'll be using it a lot. All right, now that I've added this description property, I need to let kind of the world know that book now conforms to the CustomStringConvertible protocol. So I'm going to have a colon now after book, and I'm going to list out CustomStringConvertible as one of the protocols that my book class conforms to. If I run this now, I'm going to get my title by author output from this description computed property, which is really cool. All right, so now that we can see kind of inside of our book objects, let's create more than one book object. So back in main.swift, we've got book 1. So we're going to declare another book reference, okay, to demonstrate that classes are reference types. So I'm going to have book 2, okay, which is going to be a book object, but it's not going to be a new book object. It's going to be a reference to an existing book object because I'm going to initialize it using what you might know of as like a copy constructor to book 1. So if book is a struct, this makes a copy, okay? But if book is a class, then this is not going to make a copy. This is going to make a reference. So let me print out book 1. Let me print out book 2. Okay, and we should see Harry Potter and the Sorcerer's Stone printed twice. Okay, but now let's say I make some sort of change using book 2, like book2.title. Let's say this is now Harry Potter and the Chamber of Secrets. Okay, so now I've made this change via book 2, but book 2 is a reference for book 1. So now whether I print out book 1 or book 2, I'm going to be printing out the same object, which is the one with the modified title, Harry Potter and the Chamber of Secrets. All right, let's say I make another book object, just so we can get more practice creating these book objects. So let's do book 3. I'm just going to make up some numbers here. Let's do Harry Potter and the Prisoner of Azkaban. This is my favorite Harry Potter book in the series. Now this one, I don't know how many pages it has. I know it has more. Let's say 400 pages. All right, so let's print out book 3, and then let's run this, and we'll print out a little comparison here. Let's print out, say, book 1 equal to book 3, for example. Okay, so I'm getting an error here saying that the binary operator equality cannot be applied to two book operands. Okay, so fear not, Now that we know about protocols, we'll be able to fix this with the equatable protocol. We won't do it in this video, but as you start to explore more working with OOP in Swift, you'll find that protocols are really powerful, and just like CustomStringConvertible allowed us to kind of build up more functionality for our book class, there are other protocols to build up functionality and make our kind of programmer-defined types more interchangeable. All right, so with this, I'm gonna end the video, and in the next video, we're going to work with structs. We're going to convert our book class to a book struct, and we're gonna see how things can be a little bit different. Like I said, we already know that if book is a struct, this is gonna make a copy instead of making an alias or instead of making a reference called book2 to the same object referred to by book1. All right, that is it. Thank you for watching.